So we started with these notes, right? So we talked about chapter 30.1. This was called representing categorical data. Does anyone remember what categorical was another name for? What type of data? Qualitative, good, right? So I think I wrote this down, but categorical meant qualitative. And did qualitative represent like words or numbers? Words, right? So qualitative data represents data that can be described in words like yellow or vanilla or something like that. That would be examples of qualitative data. Okay, we talked about how we can graph qualitative data. First way we talked about was the bar graph, so how to make a bar graph, which we were pretty good at. Then we started this circle graph or pie chart, right? So we started talking about how we could make a pie chart, and we had a couple formulas. So the first formula was for the proportion of observations. So for example, if we wanted to figure out if something was 35% of the whole, we would take the number of observations and divide by the total. That was the proportion. So like 0.3 or 0.5 or something like that. Now, unfortunately, like 50% doesn't translate to the angle on the pie chart because there's 360 degrees in a circle. So in order to get the angle in the pie chart, we would take the proportion like 0.2 or 0.5 or something like that and multiply it by 360, which is the total number of angles in a circle. Okay, now something like this was on your homework, right? We have a chart that gives us the type of thing that we're looking at, the number of observations of each type, and we could figure out the total number of observations by adding together everything in this column, right? So we said we had 50 observations. We took 11 divided by 50 to get the proportion of MasterCard to get the 0.22, for example. And then we multiplied these proportion numbers by 360 to get the angle in the pie chart. So that's how we got 79.2 and so on. Okay. Now I left it as a cliffhanger on how to actually make the pie chart. And what we're going to do is I have these protractors that I'm going to hand out. And we can use them to make the pie chart. 1 and 2. Yeah. 2, 3, 4, 5. Okay, so on a test or quiz, I'm never going to require you to use a protractor because protractors are kind of hard to find, and I'm not going to require you to like go out and buy one. I think I don't even know if I can find these at Walmart. But these are definitely necessary. For example, if you're teaching a class and you want to tell your kids how to make a pie chart, you might want to know how to use one of these, right? Okay, so if I have a circle graph, start with a circle, right? What I like to do is start out by drawing a dot in the center of my circle, this little dot, okay? And this kind of gives me a reference as to where I'm going to put my protractor, okay? Now, typically, when you draw a circle in like higher level math classes, on the X and Y axis, the circle is usually like in the middle, okay? Now, on the X and Y axis, 0 is here, right? So I know you can start your circle graph anywhere, but normally what we do is we draw a line from the center to the right-hand kind of middle of our circle. Okay? So the reason we do that is because that's technically where 0 is. And it's where a protractor starts too. Okay. So MasterCard is our first type. And the angle in the pie chart is 79.2 degrees, okay? I'm going to show you what to do with your protractor, okay? On our protractor, we have 2 sets of numbers. We have the ones on the inside that start at 10 on the right and go all the way to 170 on the left. And then we have numbers on the top that start from 10 on the left and then increase as we go to the right. Since I'm starting that line like on the right hand side, we're going to focus on the middle numbers. So 10, 20, 30, 40, 50, and so on. That's what we're going to focus on. Okay. First thing we're going to do, we have to make sure our protractor is in the right position. And what I mean by that is you're gonna take the center dot here and align it with the dot that you drew in the middle of your circle. Okay, and to make sure your protractor's aligned right, you're gonna make sure that this black line on your protractor is aligned with the line that you just drew. So it's kind of hard to see, but oh, that is really hard to see. I wonder if there's a light I can turn on. Nope. Okay. All right, so we want to draw an angle of 79.2. Okay, we're going to focus on the middle numbers, and I'm going to go all the way up to 70, and I want to get to 79. So once I get to 70, I know I have to be close to 80. I'm going to like look at these little notches. 79 is really close to 80 up here. I know I'm kind of encroaching on my space that I wrote here, but I'm going to draw a little dot around 79. I drew it like right above this 4. Okay. Once I've drawn the dot, I'm going to take my protractor and get the line edge. I'm going to connect the dot in the center of my circle to the dot that I just drew and draw a line from the center dot to the edge of my circle. So we made our first kind of slice. Now, of course, with a pie chart, you always have to label graphs, right? So I'm going to label this MasterCard MC. And I'm not going to write the angle in the pie chart because you can always find that with a protractor. But I am going to draw, or I'm going to write out the proportion because it's kind of hard to go from the angle to the proportion. So I'm going to put 0.22 in my graph. Okay. Now, sometimes when we see pie charts, they like to write them in percentages. So maybe instead of 0.22, I'll write 22%. Okay, so either one of those could be on the pie chart. Next question, how do we make the next slice? What I like to do is turn my page around so that my line I just drew is in like the right-hand position here. Okay. What I'm going to do now is I want to make a 165.6 angle from here. I'm going to line my circle dot with the dot in the center. Make sure that black line on the protractors against the line I just drew. So it's in position. I'm going to find 165.6 on here. Remember, going from the inside, the numbers on the inside. 165.6 is in between 160 and 170. So probably where this line is and a little bit over. Draw a dot there. Once I'm done doing that, I can connect my center dot and the dot I just drew and draw my line to the edge of the circle. So this is what our line should look like. At this point, well, I can label it like this way. Sometimes I like to turn my page around and label it so all the writing is kind of flush with each other. Visa. And 0.46 is 46%, right? So 46% of the total is Visa, and it's a big slice of my pie chart. Okay, kind of overkill, but let's do American Express. Now I'm going to turn my page again. I want to make sure that line I just drew is on the right. Going to align my center dot with the dot in the center of the circle. Make sure the black line is against the line. And I'm going to draw an angle of 64.8 going from the middle. That's between 60 and 70. So that's about here. Once I'm doing that, I can connect my circle dot and the dot in that I just drew and connect the circle to the edge of my circle. Oh gosh, the dot to the edge of my circle. Turning my page around, this is American Express or AE. And that's about 18%, right? Okay, do I have to use my protractor for the last section? No, right, because I already know all these angles add up to 360. I don't need to do it. Of course, I can check to see if I'm about right, but discover is going to be my last category, and it's 14%. Any questions on how I've made my circle graph? Okay, perfect. I have an example for you on the next page. I have something that looks like something that might be on your quiz tomorrow. I have, I want you to find the proportion, the angle in the pie chart, and I also want you to give making this pie chart a chance. All right, I'm seeing some good answers up. If you're still working, that's totally fine. I actually wrote out the chart as I was walking around. I think everyone filled out the chart pretty well. Just to go over it though, how did I find the total number of observations? Yeah, add all the number of observations together and that gave me 10, right? So for example, if I were to find the comedy proportion, what would I divide? 4/10, right? So that's how I got the 0.4. And how would I get from 0.4 to 144? Times 360, good. 0.4 times 360, that gave me the 144 and the 180. Okay, so I think all our charts look good. Is there anyone who wants to volunteer to write up or to show their pie chart? Brittany? All right. Oh, perfect. And do you kind of want to take us through how you got your pie chart? Or you don't have to go through everything, but.
For the comedy, I used the protractor and used the inner number and went to the point where it said,
It's about 144.
yeah, that one. Put a dot on the top of it, or the line towards the middle, towards the center of the top.
And then you basically did the same thing, but you you kind of shuffled your paper around so it lined up again, and then you got 180, and 180 is the whole length of this protractor, right? And then you didn't have to do anything for the drop. So very nice job here. Oh, one thing I do want to change here. I like how you put the proportions. These aren't actually percents though, right? Oh, no big deal here. The 0.4 is actually what percentage? 40%, right? So this is actually 40%. I didn't check that, but 0.5 is 50% and 0.1 is 10%, right? But very nice job, Brittany. Does anyone have any questions about her pie chart? Here. All right, so we just finished this page. If you flip over to the next page, you'll see a question that looks very similar to like your homework, for example. So we've learned how to make pie charts, but we haven't really talked about how to like extract information from a pie chart. Sometimes we might want to answer questions based on a pie chart. We're not given like all the information or all the data that we are supposed to have. So here's an example. We have 1,200 students enrolled in Adams Middle School, and we have a pie chart of all the activities that they participate in, clubs, sports, hobbies, and something else. Okay, we have a question that is asking us how many students participate in sports, okay? Any ideas on how we would answer this, Ariel?
You would multiply the 1,200 by 0.38.
Awesome, right? Times 0.38. Okay. Question, how did you get the 0.38?
So that's the proportion of students that play sports.
Okay, perfect. Let me kind of go through this slower, but very good job here. I want to find the people who are doing sports. So that's 38% of the entire student body, right? So I want to find 38% of the total, right? That's essentially what I'm doing here, okay? Now to get from 38% to 0.38, now one way you can do this is you can divide by 100, okay? I think someone said in the last class that they moved the decimal point 2 to the left, so you can also do that. But dividing that by 100 gives you 0.38. Of always means times whenever we're doing word problems, right? So whenever you see of means times. And the total number of students is 1,200. Okay. When I multiply this out, I think I got 456. Sometimes my math is wrong, but I think that's right. Oh, you can't. Okay, there you go. All right, I think I can change this to full screen. Oh, we are on full screen, okay. All right, so any questions on part A? Good. Part B, let's do this really quickly. How would we, what would we multiply to get the students participating in clubs? 1,200 times 0.25, good. To get the 0.25, you can take 25% and divide it by 100. Okay. So when we multiply these two together, we get 300. And that's the number of students participating in these clubs. Any questions on part A and B? Okay, you should be able to do everything on your homework now. And I think you might see something like this on your quiz. Okay. There is one more type of graph that's used for qualitative data that can be expressed using words. And we call this a pictograph. You might see these a lot in like the news or on social media, stuff like that, because they look kind of cool. Here's an example of a pictograph. It looks like a bar graph, but instead of bars, we're given pictures. So for example, there are 12 smiley faces. So that means 12 students walk to school, or 8 smiley faces mean that 8 students travel by car. Now, pictographs are cool. They're like bar graphs, and if they're used properly, they're kind of fun to use. Unfortunately, there's a little bit of a danger that we use with pictographs, which is why a lot of like scientific journals and stuff don't use these as often. Here's an example of a faulty pictograph. We have the junk food sales in our school, okay? Who sees what might be wrong with this pictograph? What might be misleading? Gosh, Amari?
The way it's displayed in the bigger image is usually like a size rather than like a number. Even though like in the first graph it showed like 12 individual smiley faces, this is showing one chunk.
Nice. Any other ideas? Yeah, I think you're on. I think you have the right idea. I'll just explain it slightly differently. It says last year the height is $6,000, right? $6,000, right? Okay, and this year it's $3,000. So between last year and this year, the junk food sales in our schools have decreased by half, right? Does it look like half in the pictograph? No, right? It almost looks like it's decreased like by a quarter almost, right? Because we can fit 4 of those tiny pictures in that big picture. So it's very misleading, even though it shows us the right information. If you look at it, it looks like the sales have decreased way more than they actually have, just by looking at the picture, not looking at the numbers. So there is a danger with pictographs. They're used a lot and they do look cool, but you do have to be careful when you look at this. Okay. Any questions on pictographs? All right. So I think we're ready to move on to the next section. Okay. And this section is going to talk about how we can represent data and a very specific type of data, which is called measurement data. Does anyone remember another term we can use instead of measurement data? Quantitative, perfect, right? Quantitative. Okay, and remember, quantitative data represents things that we can describe using numbers. So you can answer a question using 2 or 5 or 3.1 or something like that. Okay. We're going to talk about different ways we can represent measurement data. The first one is the easiest graph for measurement data, and we call this the line plot. Okay. Line plots, they look like this. We have a number line on the bottom, and we basically tally how many times we see that number above using X's. Okay, so let's do an example. Each student in a class is assigned a number, and we have their numbers here. To make a line plot, we should probably draw a line, right? I saw people using their protractors during class, which I didn't actually mean to do, but I think that's pretty smart. But let's just draw a little number line. Okay. Where should I start my number line? I think I heard something. Zero is good. We could even start at 0.5, but let's do 0, since that's kind of a pretty good, it's close to our lowest number, right? Where should we end our number line? 5, right? 5 seems to be our biggest number, so let's end it at 5. Okay. Now, what should the spacing be? What should each like tick mark in my number line be? Like 0.5 maybe, right? Since we got 0.5, 2.5, maybe we should include some 0.5s. And I think the most thing I struggle with is like how many tick marks to put. And I'm gonna say the easiest way to do this is to kind of just guess. And if you don't make it, just undo what you've done and try again, okay? So I'm just gonna guess that 0.5 is like here. Okay, and if I mess up, I'll just erase it and try again. Okay, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. Uh-oh, looks like I underestimated my lines, but you know, to fix it, I'm gonna do something lazy. I'll erase the edge and write 5. There we go, I made a perfect line graph. All right. How many X marks should I have above 0.5? 1, right? There's only 1.5. Looks like we got 2 2s, so I'll put 2 X marks above 2. 3 2.5s, so 3 X's go there. 4 3s. We've got 2 3.5s. 4 4s. 4 4.5s. And 2 5s. Okay. And I've made my line graph. So all you have to do is make your line, figure out where to start and stop, and draw your X's. Any questions on what I've done?
Are we allowed to do this on the test to like just make the line shorter?
Oh, yeah, you can. Yeah, as long as I don't like, sometimes I'll make the line for you. So I guess then you don't have to think about it. But if you want to make your own line, then yeah, you can just erase it. Yeah. Any other questions on the line plot? Sounds good. Okay, we don't actually have to make the line plot. Sometimes we're given a line plot and we're asked questions about the line plot, right? Okay, so here we got this line plot. How confident are you on answering these 4 questions? Pretty good. Okay, I'll give you like 2 minutes to work on these questions, and then we'll come back and discuss what the answers are. Good. Okay, let's talk about part A. How many students' scores were on the line plot? 31. And how we get that number? Yeah, you just count how many there are, right? Cool. Okay, what was the highest score? 100. And how did we get 100? Yeah. The last number on the line plot. I think I heard 80. And even though 80 had the most dots, it's not actually the highest score. 80, the dots above 80 represent the students who scored an 80. So technically the highest score is the highest like numerical value the student got. Does everyone on the same page with that? Cool. All right, what's the lowest score? 40, good. Even though 0 is on the line plot, there's no students who scored a 0. So it's definitely not 0. The student who scored the lowest is the student furthest to the left, which is 40. Okay, let me erase this. There we go. Okay, okay, let's talk about how many students scored a 70 or higher. What did we get for this one? 20, and how did we get this number? Good. I think we said we counted all these guys, right? Did we include the ones at 70? Yeah, right, because we want to find the students who scored a 70 or higher, which means we're including 70. Good. And what was the most frequent score? 80, perfect. That's the one where we have the most X's. Okay. Any questions on this example? Good. All right, flipping over, we're going to talk about one more type of quantitative graph, and this is actually called a stem and leaf plot. Anyone know what a stem and leaf plot looks like? Oh, I think I heard something. All right, I'll draw an example of what a stem and leaf plot looks like, and you'll be like, Okay, this is what this is. We've got a bunch of numbers on the left. We got this bar, and then we have like all these numbers on the right. So, let me do, I'm actually going to start here. And we'll do 7, 9, 2. Okay, this is an example of a stem and leaf plot. The left-hand side are what we call stems. And everything on the right-hand side are called leaves. And what this essentially does is it splits up every single number in our data into every digit that comes before it and then the last digit on the right. And if that doesn't make sense, let's talk about this 9. What does this 9 mean? I think I heard it. The 9 is the right number, but what number does 29 represent here? So what does this 9 mean? Like, how would you read this on the stem and leaf plot? Perfect. Yeah, this would mean 29 is a data value, right? So even though the 9 is like kind of separated from the 2, you read it as, okay, this is 20. Okay. This 2 represents 32, right? What would the 0 represent? 0, right? The 0 stem means there's just nothing before that number. So how we read a stem and leaf plot is we just look at the stem and then we combine it with the leaf, and that becomes the full number for data. Okay. When we make a stem and leaf plot, we have a couple steps. The first thing you want to do is make a vertical list of all the stems. So you want to figure out what sort of stems you're going to have. Number 2, once you figure out what the stems are, you're going to add the leaves. You're going to do this in kind of like a random order. You're just going to put them on the plot, and that'll make more sense when we do an example. We're going to finish tabulating the values. And the last step is to arrange each row in numerical order. That will make a little bit more sense if we do the example. Okay, let's do this one. So we have Miss Santos, and she has collected data. She asked her 23 students to estimate the length in feet of the classroom they were in. It was actually 43, but we have different answers. And here are the results, okay? Let's try to make a stem and leaf plot, okay? So I want to make my stems, which represent the leftmost number, leftmost digit of my numbers. What do you think my stems are going to be?
3, 4, 5, 6.
There's actually a 2 hidden there too. If you look closely, there's a 24.
Oh.
Yeah, I made that mistake last class, so that's why I know that. All right, so we got 2, 3, 4, 5, and 6. These are all the leftmost digits of my numbers. Once I've made my stems, I'm just going to go through and randomly put things into each category, okay? So I have a 35. I know that 5 is going to go next to the 3, right? So that reads as 35, okay? You can put commas if you want to. You don't have to put commas to separate your digits. I'll do it first. Oh, yeah. Oh, for the 35? Oh, okay. Oh, for 30, yes, we'll put the 0 next. Oh, okay, I see what you're saying. So you're asking, does 30, should I put a 0 or just not put it? We actually do put it, and the 0 there represents a 30. Yeah, so for this 30, I'll put a 0 next to the 30. Good question. All right, 40, that's going to be a 0 next to the 4, right? Okay. We got 32. I'll fill this out a little bit faster. We got a 46. We got a 45. We've got a 54, a 36. We have another 45. Should I put another 5 or should I leave it alone? Yeah, put it again. So you can repeat things in your stem and leaf plot if you want to. We've got another 30, so another 0 goes in there. We've got a 55, 2 40s, a 60, a 40, a 44, 42, a 30, a 24, a 60, a 42, another 42, and lastly, another 40. So I've just put everything in their categories based on what their first digit was. Oh, area.
So why not put them in numerical order from the jump?
You can do that. The problem is if I went through here and tried to put it in numerical order, so make this row numerical order, it might be, I find it kind of hard. If you want to do it right from the beginning, it's fine. This is just like how I do it. I find it easier this way, but I'm not gonna like take off points if you do it right away. Yeah, good question. Any other questions? All right. So this is kind of like my scratch work. Now what I'm gonna do is I'm gonna finish my stem and leaf plot. I'm gonna write another one on the bottom of the page. And I'm gonna go through each row and make sure that each of them are increasing as I read from left to right. So the 4 stays the same. 3's got 3 zeros. I've got 1, 2, a 5, and a 6, okay? Now I'm not putting commas on this one just because you can do it either way. So you can put commas if you want. You can leave the commas away if you don't want them. So it doesn't matter to me. Going to the 40 column, we got 1, 2, 3, 4, 5 zeros. We got 3 2s. We got 1 4, 2 5s, and a 6. We got the 4 and a 5 and 2 zeros on the 6. Okay. Yeah, so if you can do the last part on your like right away, definitely go ahead and do that. But for some reason, I'm a little bit less organized, and I need the top one for some reason. Okay, this is our final stem and leaf plot. Okay. Any questions on this example? Okay. All right. I think it's quiz review time. So we're actually gonna leave this aside for next class. And if you're looking for the quiz review and you're on Zoom, I need to stop my share. So if you ever want to look at this later, I'm just going to leave the meeting. I'm going to, oh my goodness. If you're ever looking for it, it's under modules at the end, and I'll post the answers to this later today. But for now, I'll pass this out. Since I'm posting the answers